Mr. Hyatt here. This is the Chapter 10 APES lecture, all about water and water pollution. This chapter starts out with a case study on the Colorado River. Faces a lot of challenges. Overuse of the river challenges state and federal agencies and the people who live in these regions. Water levels are dropping, things along those lines. Increasing population and economic development place increasing demands on the limited supply of water. We know that from the fall. So think about where your household water comes from and how you could conserve water use in your own home. So here's the Colorado River Basin, and if you notice, excuse me, it kind of originates up here in the mountains, and then carries the Colorado River, carries water down this way. Okay, so the challenge, I guess, or the reason this particular water supply is specifically or is overtaxed is, look right here, San Diego, LA, let's see, Vegas, let's see, well, there's the Grand Canyon, there's Phoenix, there's Tucson. All these major metropolitan areas get their water from the Colorado River Basin. So as population growth goes crazy, more and more people need the same water. So that's not good. You can see here there are quite a few dams. There are 14 dams on this one river, just trying to control how much water is available at different places. Anytime you're damming up water, you're hurting what's downstream. So why is fresh water in short supply? Well, we use a ton of it. We know from the fall that we use a ton of it in animal agriculture. We use a ton of it ourselves. 1 in 9 people on Earth don't have access to clean, fresh water. So that's a troublingly high number of people that don't have access to something as basic as fresh water. Another reason that water is in short supply is we don't take care of our water well. We do have plenty of fresh water. It's roughly 3% of the water on Earth is fresh. 1% of that's locked up in glaciers. So we have about 2% of the water on Earth is fresh water. That's enough. That's enough for the human population. But because we do what we do and we pollute and we overuse it, it's not enough. Causes economic and security issues. I've seen several things that predict that we're going to have water wars in the future. It's definitely a health issue because you've got people, if you don't have access to clean water, you still got to have water. So you might compromise how clean your water supply is. If it's drink tainted water or die, you're probably going to drink the tainted water. And then, of course, it's an environmental issue because fresh water moderates climate, dilutes and removes pollutants and waste, and all the things that we talked about in the fall. There are huge freshwater resources. Groundwater is going to infiltrate downward through spaces in soil and rocks, so it's going to filter down to the water table. There's some huge vocab on this slide. Last year I did not do a good enough job of emphasizing this vocab, so make sure that you're maybe defining these, maybe practicing with them on Quizlet, something like that. So groundwater is going to be water that's on the ground. Zone of saturation is going to be an underground area where fresh water fills the spaces between particles. Picture in your head like a fish tank. At the bottom there are all the rocks, and then you put a bunch of water in it, and water fills the spaces between the rocks. That's what the zone of saturation is like. The water table is going to be the top of the groundwater zone that moves up and down depending on weather and removal and replenishment and all that kind of stuff. The water table is where we get our water for our homes and things like that. And then an aquifer is going to be an underground body of water that absorbs and holds flowing water. Sometimes they're called underground rivers, things like that. Just massive underground bodies of water. We also have surface water, which is what it sounds like. It's water that's on the surface. You can walk up to it. That would even include like a lake or a pond. Reliable surface runoff is going to be surface water that generally can be counted on as a stable source of water. So that's going to be something like snow melt. It's a type of water that's on the surface that's always there. And virtual water, that's kind of like what we talked about with animal agriculture. It's the water used to produce other things that we consume. That's mostly vocab. A little bit more vocab here. Water scarcity is caused by dry climate, drought, overuse, and inefficient use. Duh. You're wasting it, or you don't have enough of it, so there's not enough of it. We can calculate that. I'm not going to ask you to, but it's possible to do that. But more than 30 countries now face freshwater scarcity stress. 30 countries. That's crazy. So how can we increase freshwater supplies? Well, you can use less because we're using tons of it for food production and use it in our homes. We can use dams. They're helpful with the water aspect, but they also disrupt ecosystems and sometimes displace people. Sometimes a reservoir, sometimes people live on where a reservoir is going to be formed. There are several examples of this. There's one here in central Indiana. I grew up going to Raccoon Lake, not too far from here, and there's a road that used to go under Raccoon Lake, so they flooded over that road. If you've ever been down to Dale Hollow, you can scuba down and see some, there's an old church and there are some old houses and things like that have just been flooded to create the ecosystems. Certainly you're going to mess up natural ecosystems. You're going to take what was a grassland or a forest and you're going to make it a lake. And then desalinization is expensive. Remember, how can people increase freshwater supplies? Lots of people say, well, why don't you just turn saltwater into freshwater? Seems easy enough. It's not. It's expensive. It's energy intensive. We'll look at it a little bit. So our aquifers, which remember are those deep underground water sources, are being used faster than they're replenishing. We're pumping tons of water out and using them, and that's going to cause the gap between the rich and the poor to widen due to increased food prices, things along those lines. Like it says there on that first dash, as the water tables drop, you got to go deeper. So it takes more pipe, it takes more drill time, takes more electricity, takes more carbon dioxide to power the drill, just takes more. It causes land subsistence and sinkhole development. Did I say subsistence? Subsidence. The land gets worse where the aquifers are collapsing, making the recharge impossible. And if the aquifer drops far enough, salt water will come into the aquifer, and that taints it and makes it unusable for anything that really needs fresh water. So what you're looking at here is a map of some aquifer depletions. Notice we got a couple of red dots here around Indiana. The big section that you see here, this is called the Ogallala Aquifer, and we're going to look specifically at how the Ogallala Aquifer pulled us out of the Dust Bowl and what's happened to it since that time, since the time of the Depression. So I mentioned dams earlier. Let's spend a minute looking at dams and what they do and kind of some of the drawbacks. So a reservoir, we have several reservoirs around here. I mentioned Raccoon Lake, which is Cecil M. Hardin Lake is the real name of it. Mississinawa up in northern Indiana is a reservoir. We have many reservoirs here in Indiana. Difference between a reservoir and a lake is that we create a reservoir with a dam. A lake gets filled up by water. They do a great job of capturing and storing surface runoff from a river's watershed. Then when you need water, you can control how much is coming out. You can generate electricity using hydropower. You can supply fresh water. You're making a lake, so now you can swim in it. You can ski in it. You can use that reservoir for things that you couldn't previously. And then a water transfer project versus a dam, that's going to be something like an aqueduct where we're going to move water from one place to another. That's often a common suggestion. Oh, we don't have enough water. California's going through a massive drought. Okay, let's build a pipeline from central Indiana because we've got too much water, and we'll just pipe our water someplace else. In theory, that sounds good, but you know as well as I do, you build a pipeline, you have to destroy ecosystems to get water from A to B. You got to pump the water, it takes electricity, so that has some serious drawbacks. And I guess I should have just gone to the next slide to say that. Let's talk about dam and reservoir first. Displace tons of people, flood productive lands. That's another thing I omitted earlier. That grassland or that forest that you're flooding maybe is really productive farm ground. It's going to impair the ecosystem services of rivers because you don't have flowing water, now you have stagnant water. And most dams, most reservoirs only have a life expectancy of about 50 years. It wasn't too long ago maybe 7, 8, maybe 10 years ago, I used to go up to Mississinawa a lot when I was in middle school and high school with my parents, and we used to camp up there all the time. There was like a 4-year period where they drained it, and it was not a reservoir. It was a grassland. And they were trying to get rid of some invasive species, and there were just some buildup of some aquatic toxins and things like that they just wanted to reset the ecosystem. So I can't remember exactly how long it lasted, but 3 or 4 years they drained the reservoir. And I know that they've periodically done that with Raccoon Lake as well. You just kind of have to reset it, and then you can close the dam again, you can reflood the reservoir, and you've got your lake again. Like I said earlier, water transfer projects have issues. In theory, it's a good idea, get it from where it is to where it needs to be, but it's not quite as effective in practice as it is in theory. I hope you brought your binoculars for this slide, because you darn sure can't read it on the screen. So what I would do if I were you is look at this in your textbook. Make sure you take note of how hydroelectric power works. Really soon we're going to start talking about alternative energies, and it's all about turning a turbine. If you can turn a turbine, you can make electricity. If you can turn a wheel, you can make electricity. So start to pick up on all of those ways, the different ways you can turn a turbine. You can push water through it, you can put air through it, you can turn it manually, somehow, some way, you can ride it like a bicycle, somehow, some way, you spin a wheel, you create electricity. So 10.3, how can we use freshwater more sustainably? Well, we could reduce waste. We could raise prices. Reducing waste, imagine if we came up with a shower head that used a quarter of the water, and everybody adopted it. Everybody across the country improved it. Or the big push in the last, 15 years maybe, has been Energy Star appliances. Well, some of that's electricity, but a lot of that's water use too. My washer uses like a third of the water that my last washer used, and it's bigger. So systematically, we're reducing our waste. It's not just don't leave your faucets running overnight or turn your hose off when you're done looking at it. Sometimes it's how can you, does it help to get a low flow toilet? Or how many times do you flush a toilet? Well, if you can save a gallon of water every time you flush a toilet, great. Can you do gray water capture, something like that? Raise prices, make water more expensive. I know that my current house water is way more expensive than it was when I lived in town. So we've done several things to try to reduce our freshwater use just because we can't afford it. It's just too expensive to use water for all the things that we're using water for when we lived in town. So that definitely works. We could slow population growth. Good luck with that. Protect ecosystems that store water naturally, like forests, or protect our swamplands and our marshlands and our wetlands and all those types of things that we talked about as good practices in the fall. How can we reduce freshwater losses? Well, most of it's due to evaporation and inefficient use from irrigation. So improve our water use in farming. Use drip irrigation instead of flood irrigation. Use central pivot irrigation, where you've got a sprinkler that spins in a circle around everything, and you can control the water use that way. Government subsidies, of course, always can manipulate a market, and then lack of subsidies for efficient water use. Again, those things can kind of play off of one another. Here's our irrigation stuff that we talked about. A couple of you did presentations over these. You got gravity flow, where you're kind of on a hill and you dump the water here and gravity pulls it down. Drip irrigation, we talked about, it's like you take a hose and you stab holes in it, and gradually, slowly, water leaks out of the hose and waters the crops. And here's that central pivot, where it's like a sprinkler on a rod that turns in a circle and waters the crops. There's a really good example of this near Lebanon. There's a big sod farm that uses a center pivot setup like this. Other solutions that your book suggests: avoid growing thirsty crops in dry areas. That kind of connects with our Cowspiracy movie, where the guy talked about, well, if they have to do all that to grow cows, they don't need to eat beef. Well, if you don't have a lot of water, you need to grow drought-favorable crops. And then you can kind of read through these. These, I think, all make sense. So we'll leave off there and pick up there at video 2.